Okay, now let's look at exercise 15.1 question 2. Okay, if you haven't tried this by yourself, please pause the video now and try it first, okay, before you check the answers. So in this question, we are given the function y equals to x over x squared plus 1 for x more than 1. And we are asked to find in part A an expression for dy over dx. Okay, so before we do the expression for dy over dx, let us simplify this. Okay, I can rewrite y as x times x squared plus 1 to the power negative 1. Okay, I do this so that I can use the product rule. So dy over dx, if I use the product rule, will be, okay, let me keep x, differentiate the other term, times negative 1, x squared plus 1 to the power negative 2, and then I have to differentiate inside, which gives me 2x plus, okay, I keep x squared plus 1 to the power of negative 1, and I differentiate x, I'll get 1. Okay, simplify this, I will get negative 2x squared over x squared plus 1 squared plus 1 over x squared plus 1. If I want to express this as a common denominator, x squared plus 1 squared, I will get negative 2x squared plus x squared plus 1. And this works out to be 1 minus x squared over x squared plus 1 squared. And in the next part, you are supposed to show that if x is more than 1, then, okay, this is a decreasing function. So first of all, okay, we know that dy over dx is equals to this. Now in part B, we know that if you want to show for x greater than 1. Okay, we have to look at dy over dx. Our aim is to prove that dy over dx is less than 0 to show that it's a decreasing function. So let's look at this. Okay, let's try to figure out the denominator first. We know that for x more than 1, alright, we have x squared plus 1 squared must definitely be more than 0. Right? This is because of the square here. Which therefore we know that the minimum value of x squared must be 0. Therefore, if we take 0 plus 1, okay, the minimum value of this term here is actually 1. Therefore, it's greater than 0. Now, how about the numerator? Okay, for x more than 1, we know that x squared must therefore, okay, be also more than 1 square. So, x squared must be more than 1. Now, if x squared is more than 1, then what happens to 1 minus x squared? Okay. You find that, okay, if you move 1 over x squared over to this side, you get 0 is more than 1 minus x squared. And you find that 1 minus x squared therefore is less than 0. So over here you have the denominator is more than 0 but the numerator is less than 0. So when you take a negative number divided by a positive number, what you end up with, okay, which is dy over dx. Remember, this one is negative, okay, as we've proven over here, the denominator is positive. So we end up with something that is less than 0 for x is more than 1. And once we've shown this, we can therefore show that y is a decreasing function for x is more than 1. Okay, so the key to this here is to show that dy over dx is less than 0.